Hello guys, my name is Bino and in this video we'll be going through question 10 from the November 2021 final examination question paper, question 10.1. But before that, in the diagram, BE and CD are diameters of a circle having M as center. So we have BE and CD. We are told that these are our diameters. Chord AE is drawn out to cut CD at F. So here's our chord AE. Is cutting that CD at F. AE is perpendicular to CD, so they've already included that with that perpendicular sign. Let C, angle C, equal X. So that's our angle X as indicated on our diagram. So question 10.1, give a reason why AF is equals to FE. So why is this equals to that? So we can see that this is from the center and it's cutting through chord AE and it's cutting through chord AE perpendicular. So that's going to be our reason, because we know that there is a theorem which states that a line segment cutting through the center perpendicular to a chord bisects the chord. So by bisect, we mean that it will divide the chord into two equal sections. So that's our reason for question 10.1. Question 10.2. To determine given reasons the size of M1 in terms of X. So we are looking for the size of that M1 in terms of X, and we can see that M1 is bounded by the line ME and the line MC. And if we were to introduce chord CE, that chord CE will also be common to this triangle EAC. And we know that the angle which will be in the middle will be twice the angle which is at the circumference. So M1 will be equals to 2 times the angle which is at the circumference. We have chord CE subtending this triangle and that triangle. So that's why we expect that M1 will be twice the angle which is at the circumference. But we are looking for M1 in terms of X, not in terms of A1. Let's erase this and get a fresh perspective. So we are looking for M1 in terms of X and not A1. You can see that there is triangle CAF, and we know that the angles inside a triangle add up to 180 degrees. So we expect that A1 plus that X plus that 90 degrees will add up to 180 degrees. So we have the first angle as A1, the second angle inside the triangle is our X, third angle is that 90 degrees. They should all add up to 180 degrees. So A1 will be equals to 180 degrees. We take the 90 and the X to the right, they will change sign from positive to negative. So our A1 will be equals to 180 degrees minus 90, which is equals to 90 degrees. A1 will be equals to 90 degrees minus X. But it is not A1 that you are looking for, we are looking for M1. So since M1 is twice A1, where there is this A1, we can substitute 90 minus X, because 90 minus X is equals to A1. So you substitute 90 degrees minus X in the place of the A1. So our M1 will be equals to 2 multiplied by 90 degrees is equals to 180. 2 multiplied by negative X will be equals to negative 2X. So our M1 in terms of X will be equals to 180 degrees minus 2X. Moving on to question 10.3. Prove given reasons that AD is a tangent to the circle passing through A, C, and F. We have A, C, and F, which lies on a circle. So that's our circle. So let's draw the tangent AD. So we are saying that there is a circle which passes through A, C, and F, and that circle is tangent to the line AD. So we have to prove that. So we can see that inside this circle there is a triangle, and that triangle touches the tangent AD, and both of the other vertices are on the circumference of the circle. So we expect that that angle should be equal to that angle, because there is a theorem which states that an exterior angle of a cyclic triangle is equal to the opposite interior angle. So here's our opposite interior angle, so that and that they should be equal to each other. If we can prove that this angle is equal to that angle, then we will have proved that AD is a tangent to the circle passing through AC and F. Is A2 equals to X? If we can prove this, then we know that AD will be a tangent to the circle which passes through AC and F. So how do we prove that A2 is equals to X? So let's get a new perspective from our circle. We have this triangle, and we can see that it is passing through the center. So CD is the diameter, so we expect this to be 180 degrees. There is a theorem which states that the angle which is in the middle will be twice the angle which is at the circumference. So we expect A1 plus A2 to be equal to 90 degrees, because 90 is half of 180 degrees. And if we were to also draw this triangle, we have already proved from 10.2 by drawing this triangle that A1 will be equals to 90 degrees minus X, because the angle which are inside must add up to 180 degrees. So we got that A1 is equals to 90 degrees minus X from 10.2. So let's see. So we have A1 plus A2 is equals to 90 degrees, and A1 is equals to 90 degrees minus X. Where there is A1, we will substitute 90 degrees minus X, because A1 is equals to 90 degrees minus X. So we substitute 90 degrees minus X in the place of that A1, and we continue with the A2, and the equals to 90 degrees. So we take the 90 and the negative X to the right, they will change sign. So the positive 90 degrees will change sign to negative 90 degrees. The X will change sign from negative X to positive X. So our A2 will be equal to 90 degrees minus 90, which is 0, plus X is equals to X. So our A2 is equals to X. So we have proved that A2 is equals to X. So AD is a tangent to the circle passing through A, C, and F, because you know that the exterior angle of a cyclic triangle is equal to the opposite interior angle. Question 10.4, given that CF is equals to 6 units and AB is equals to 24 units, calculate, given reasons, the length of AE. So that AB is equals to 24, while that CF is equals to 6 units. So now we have to determine the length AE. From question 10.1, we proved that AF is equals to FE. We proved that that AF will be equals to that FE. And we can also realize from here that BM is our radius. Also, ME is our radius. So we can also say that ME is equals to BM or MB. So here's the situation that we have. So we extract the triangle out of the circle. We have E as the apex. We have A there and our B, our F and our M. So we are saying that that is equals to EF is equals to FA, and also that EM is equals to MB. So if this is the case, then we know AB will then be equals to 2 times FM, provided that if we have 180 at the center, half 180 is equals to 90 degrees. EM is equals to MB. So we can use this formula. So we already have AB as 24. So what will be the value of Fm? We divide both sides of the equation by 2. So Fm will be equals to 24 divided by 2, which is equals to 12 units. So Fm, there's our Fm, will be equals to 12 units. So Fm is equals to 12 units. So we shift our focus to the cycle. From here, we can see that from C to M is the radius. So the radius is equals to Cm, and that Cm is equals to Cf, which is equals to 6, plus Fm, which is equals to 12. So 6 plus 12 will be equals to 18 units. So our radius is equals to 18 units. So if the radius is equals to 18 units, then our diameter is 2 times the radius. So 2 multiplied by 18 will be equals to 36 units. So our diameter is equals to 36 units. So let me redraw this again. So we have been given AB, we have to look for AE, and this is our radius, another radius. So it's a diameter, and the diameter is equals to 36 units. So if this is the diameter, then this angle is equals to 180 degrees. The angle which is at the center will be double the angle which is at the circle or at the circumference. If this is equals to 90 degrees, then we can use theorem of Pythagoras on this triangle to determine the length of AE. So we can see that if we were to say that this is our triangle, then the radius of this triangle, not the radius of the circle, but the radius of this triangle will be equals to that BE. So we are using theorem of Pythagoras. We focus on the triangle, and when you talk about the radius, we are not talking about the radius of the circle, we are talking about the radius of theorem of Pythagoras. So BE squared will be equals to AB squared plus AE squared. So BE is equals to 36, but it's squared. AB is equals to 24. It's also squared, and we are looking for AE. We make AE the subject of the formula. So this will be equals to 36 squared minus 24 squared. We introduce the square root both sides of the equation. The square root and the square will cancel out each other such that AE will be equals to the square root of 36 squared minus 24. So we have 36, the square root of 36 squared minus 24 squared. This will be equals to 12 times the square root of 5, and this will then be equals to 26,833 units as our AE. So if you have any questions, you can leave them in the comment section below. Remember to subscribe, like, and share this YouTube channel with your fellow mates.